get into like the main part of the chapter, which again is taking two triangles and saying that they're congruent to each other. I'm going to go through a few properties with isosceles triangles and equilateral triangles. So we're covering this first because when we do the proofs, like the main idea of the proofs is we're just trying to find like pairs of things that are going to be equal. If you're dealing with these two types of triangles, you can match up pairs fairly quickly with specific angles or maybe sides. Okay, an isosceles triangle, this just means that two sides are congruent. Okay, that's the basic definition of it. This should not be the only way you guys identify these things. Okay, so if I took this triangle here and I just marked those two sides as congruent, then it would be an isosceles triangle. If I had nothing marked on it, it would just be a triangle. Technically a scalene since nothing is marked there. When you are dealing with an isosceles triangle, they'll use terms like base and legs. The congruent sides, those are the ones that they call the legs. So if they're doing a problem, they say the legs of an isosceles triangle are 8. That's just telling you the two sides that are going to be equal would be 8. Okay, so if they say isosceles triangle and leg, they're basically telling you in the directions which, like the length or variables or something to put on those two sides that are congruent. The other side is considered the base. It doesn't have to be on the bottom. Base no longer means on the bottom, guys. That's a classification form. These angles right here, this angle here, and this one here, these two angles that are touching the bases, right there. These things are called base angles. So again, like this is something so that in the directions, they say the base angles of an isosceles triangle are 20. That means you can make a sketch of a triangle, put 20 on these two, and go with it. This angle up here, sometimes called the vertex angle. Okay, so basic terms which entail you, like allow you to set problems up. If you look through all that stuff I just had listed at the beginning about what I was going to go through, there was a theorem that said like base angles theorem. Okay. All the base angles theorem says is that if you got an isosceles triangle, the base angles are congruent. Okay. So what this theorem, if I wrote it down just real basically, this just says base angles are congruent in isosceles triangle. Okay? Meaning you guys are going to be required to recognize an isosceles triangle either drawn like that where they mark the two sides congruent, or like that where they'd have two angles congruent. So you guys are going to have to be able to recognize, and this is like a requirement, just something you have to be able to get used to. So however much time it takes you, so be it, but you need to be able to get to the point where you can look at this picture and you can look at this picture and say those are both isosceles triangles. The way you guys are going to be doing work with these is these base angles, if I drew it in over here, like the parts that are congruent in terms of the shape are always going to be directly opposite each other. Meaning like the two legs are marked congruent and they are directly opposite of the two angles that are marked congruent. So if I gave you a picture like this, this would kind of direct you to saying that side and that side are congruent. If I had a picture with these marked, I would say that angle and that one. And again, don't think of, like, this is not the only orientation for it. I could turn it, I could flip it, I could do whatever I want with it. So that if I had, let's just say drawn this way, Those would be my legs. That would be my base. Okay, even though it's not on the bottom, it's still the base because it's the one side that's not congruent. So this would be an isosceles triangle. That angle and that one would be congruent because of that theorem. When we start into the proofs tomorrow, this is going to give you kind of a shortcut for finding a quick pair of angles, which is always a good thing when we start doing the proofs. Okay. All right, equilateral triangles. So this is all sides congruent. And we don't really use it, but just if you need a side word, right? Scalene triangle is no congruent sides. There's just no specific properties with that we haven't, that like we're not adding to it. Like the angles still add up to 180, but other than that, that's it. With equilateral triangles, there aren't like legs and bases here because all the sides are the same, so we're not going to have a distinction between each one. The one thing you guys are going to have to use this with is going to be the fact that if all the sides are congruent, that means all the angles are going to be congruent. And if all of these angles are congruent, they're going to be a very specific measurement because these three angles should add up to how much? 180. So if I know they all add up to 180 and they're all the exact same measure, if I divide that by 3, that would tell me the one angle, so 60. So the all angles are congruent, or you can put in parentheses, they're all 60 degrees. So again, you guys are gonna, it's as a requirement, it's going to be, if you see that, that's an equilateral triangle. If you see that, that's an equilateral triangle. Okay, you have to get to the point where you can recognize it in both situations. All right, more than likely what's going to happen is if they have all the angles marked, they'll give you some work with like the sides. Like they'll put an X there and put an 8. And they'll say solve for X. And it's just a matter of you recognizing, hey, if all the angles are congruent, all the sides have to be congruent, so therefore that would be 8. Right, fine. So this one we're just going to pretend it doesn't exist. So here's the way you should think about these. Like this isn't necessarily a difficult problem. But no matter what happens when you have an isosceles triangle, what I would kind of want you to get in the habit of doing is going, if that's isosceles and these two sides are the legs, I'll make that the base. And I know the two angles that are on the base, meaning this angle and this one, have to be congruent to each other. That's what the base angles theorem said. So I know whatever measurement I get here, it's going to be the same as when I get there. How am I going to figure it out? Alright, so I heard equals 180, so I'm doing, what you said, 180 minus 40, and that gives me what? So that means that between these two angles I have 140 degrees, correct? It's got to be split evenly because they're both the exact same number, so they're both 7. Okay? The same principle will go here, I'm just not going to go through that again. Alright, for this one over here, again, pretending this doesn't exist, it's not there. If I looked at this whole thing, that would be an isosceles triangle. Okay? Meaning that if this is 52 degrees, so is that, because those are my legs, right? That's my base right here, so the two angles on the base have to be the same. If I knew this angle was 52, and this angle was 52, and again, I'm doing this as if that line's not there. Could you guys figure out what that angle is right there? Yeah, doing what? Subtract from 180. Okay, so what is 52? 52 is 104. Minus 180 is what? 76. Okay? Alright, so now if I come back over here, and I just found out this entire thing is 76. If you look at it, these are two marks, and they're staggered, and I said, look, if they give you the staggered marks, it's telling you that it's congruent. Okay, so this 76 degree angle is being split in half here. What's 76? Ooh, 76 divided by 2. 3 what? 8. So 38, 38. I got X. Alright, Y in this case is on the side. Okay? if you see this, it's an isosceles triangle. This line right here is coming from a vertex angle, and it's split in half. Basically what that thing is doing, if you see this, something being split in half, it's splitting the whole triangle in half. So that even when you come to this side, if this is 4 up here, for this to be an actual isosceles triangle, that also has to be 4. This one right here, 2 triangles there, yes? This one right here, what kind of triangle is this one? The one on top, like a equilateral. It's equilateral, right? And again, I know it's equilateral because I've got 3 angles that are marked congruent. What kind of triangle is this one down here? Because I got how many angles marked congruent? 2. So 2 angles congruent means isosceles, 3 is equilateral. So since this one's equilateral, can I put a 56 here? Like this side's 56, which means that side 56? Yeah. Is this one 56? Okay. Since these 2 angles that are congruent in the isosceles are on this line, it makes that the base, which makes that a leg, makes that a leg. And according to what we already talked about, isosceles triangles, the legs are congruent. So if I got 56 there, I got that equal 56. Hopefully you can solve for x in that case. What's 56 divided by 8? Sure? So this is essentially what the main focus of the chapter is. Like the first bit, because we do majority of the stuff with triangles, that's the reason we go through isosceles and equilateral. But the main focus of the chapter is for you to be able to take 2 polygons, so 2, what you guys call shapes, polygons, not counting circles, but taking 2 polygons and deciding if they are congruent, which the idea of what congruent is still isn't changing. Congruent just means that they're the same size and the same shape, which is pretty much what the definition is from the beginning of the year. So if it's up there right now, this is the definition of congruent polygons, and it's also the work you need to do to figure out if 2 shapes are congruent. Meaning if you've got a problem where there's 2 shapes there, and the directions say, are these shapes congruent? This is everything you do. All right, so we'll go through and say how to do corresponding parts, but it's pretty much you write a list of all of the corresponding parts. Then you see if those corresponding parts are congruent to each other, and if they are, then the shapes are congruent. So it's going to be an act of basically making sure you list out all of the parts that make up that shape. So all the sides and all the angles. And if it was the circle, then we'd just really just be looking at the radius, but you don't run into circles. This is all polygons. Okay? So the rest of today is going to focus on being able to match up corresponding parts, and then how to write a congruency statement, and then how to use a congruency statement. Okay? And then we'll get into the triangle stuff tomorrow. All right, I can go past this, yeah? Okay, so now in the definition that was up there, right, it said, well, no, I broke it down. Corresponding parts, if they say that in general, that's just talking about the sides and angles. Okay, I used this before when I said the word corresponding, when we did corresponding angles, with the transversals and the parallel lines. The definition I had there is the same one you're going to be using now. If you took essentially the 2 shapes you're working with, stuck them on top of each other, like so everything looked like it lined up, pretty much the same, then the parts that are overlapping are going to be your corresponding parts. If the pictures are nicely marked for you like these two are, you would simply just go through and match up the things that have the same congruency, like the same number of like dashes or arcs on them. But really what it comes down to is if I took this triangle and stacked it on top of this one, and stacked it so that it looked like the parts were the same length, then the parts that are sitting on top of each other would be your corresponding parts. Okay? So if the problem came out and they had these two pictures there, and I said, are these two shapes congruent to each other? Like that was the entire problem. Right? You had two shapes, and the question was simply, are they congruent? As of right now, the way you guys would have to work with that problem would be make a list of all the corresponding parts. So you'll have a column where it just says like corresponding angles, and then you'll have one for the corresponding sides. So you just list out the pairs there. In this case, since these are both triangles, you're going to have 3 pairs here, 3 pairs there. If it was 5-sided figures, then you'd have 5 of each, 6, so on. So the more sides, the more work there is to do. So if I went through and listed these out, let's see, we'll start with E. If I said, all right, angle E is here. And the idea again is I'm matching up an angle from this shape to one that's over here that would be in the same position if they were like sitting on top of each other. So if I looked at angle E, which one do you think it corresponds to over there?
S.
What about F?
T.
T. T, and then the other one's left is D and
R.
Okay. Then I would make a list of, again, all the sides. So now I'm looking at segments as opposed to angles. So if I started, let's start with DE. So if I said, all right, segment DE, so that's there, RS, RS, EF, and
TS.
S. It doesn't matter. And then which one did I do? FD and which one?
R.
Okay, so this would be your first step. This is what would be considered the work portion for a question of, are these two shapes congruent? So I'm going to tell you now, if the directions say, are these shapes congruent, you need to make these lists out. The number of pairs you write out is going to be equal to however many sides there are, however many angles you see. Once you do this part, then you would go back through and you would check them like one by one, going, are these two angles congruent to each other? Well, again, I said this thing is nicely marked because everything is marked congruent. So are these two angles, E and S, marked congruent? Are they congruent? Yes or no? Yeah, they got the marks there. What about F and T? Yeah, what about these two?
Yeah.
Yeah. When you're doing this, guys, when the problem says, again, I keep repeating this because someone's going to go, you're going to get a homework problem that says, how do you show they're congruent? I said it like 20 times here. Keep up. When you're doing a problem like this, and the question again is, are the shapes congruent? And you made your list. I would do these first because usually it's easier to tell if the angles are congruent to each other. Because if you get even one no here, you can just stop the problem and say they're not congruent. Then you won't have to worry about this jump. All right. So once I have all of these being congruent, I say, all right, I'm good here. I'm going to go on. I move to here and I do the same kind of thing. I look at these two segments and go, well, are these two segments marked congruent to each other? Are they DE and RS? Are they marked congruent?
Yeah.
Go. Are these congruent?
Yeah.
Yeah. Are these?
Yes.
So once you go through all of this stuff, okay, then you could finally answer the question of, are the shapes congruent? Which it'd be yes, because these are all congruent and these are all congruent. So that means the triangles are congruent. And that would have been the whole question again. The whole question would have just been, are the shapes congruent? All right? It requires a little bit of work right now. Once you get to this part, then they'll probably ask you to write something out called congruency statement. Okay? The congruency statement is you just saying which two shapes are congruent. Like not by just saying the two triangles, like labeling them with the letters now. When you write this, and again, this is just saying which two shapes are congruent. The order you write the letters matters a little bit in terms of the second one you write is going to matter. So if I was to say this triangle right here is congruent to this one because of all this stuff I did over here, I can start with DEF, that's fine. So congruency statement is you start with one of the shapes, write out the letters. If it's a triangle, you put a little triangle in front. Any other shape, you don't need a little symbol. Try yourself a little congruency mark. And then you put the other triangle it's congruent to. But when you write this one out, the letters have to match up correspondingly to what's here. Meaning, if I started out with D here, the first letter over here has to be the angle that corresponds to D. So if we go back to over here, D and R are corresponding because I had them matched up, so R goes there. The middle letter I have is E, so the middle over here has to correspond to E, which was which one? And then T is the other. Okay? So these letters, this side is going to matter. This side has to match up with this one. So if you wrote out like, if you just wrote out the letters like D, E, F, and T, S, R or something, that'd be wrong because D and T don't correspond. If you change the order of the first one, like if I did this triangle first, FED, that just means when I write the second one out, I also have to change the letters now. Because F is the first letter, so the first letter here has to correspond to F, which was T. Was it S still?
Yeah. TSR.
And again, the order these things are written in matter. Okay? The order tells you how to set the problems up. So I'm giving you shapes. I'm giving you a congruency statement and saying basically solve for the variables. All right? That congruency statement that's up there, the way this is written. Okay? Even if I did not have those pictures there, if I just had this congruency statement, I could tell you which angles have to be the same measure. Okay, just by the ordering of the letters. So I can look at this thing and I can tell you that angle Z is congruent to angle T because these are the first letters. Angle X and angle R are congruent because they're the middle, and Y and S also have to be congruent. So when you get to a problem like this, and you see two shapes, and they want you to find like a side length or an angle, and there's no tricks to it because there's no theorems, but they give you a congruency statement. This thing tells you how to set it up. I could also match up segments the same way. Like even if I did not see these, if I looked at X, Y, two letters would create a segment. I know that X, Y has to be congruent to whatever segment makes up the last two letters there. Okay, it's kind of just a matching game. All right, because once you have these out, and I'm only looking at these for this problem because those are only angles. If I had segments, I would go into all the pairs there. But I can use these three statements to kind of solve this out. Like the B that's here, the 5B minus 3 is at angle Z. So if I know which angle Z is congruent to, which I do, it's T, I should be able to set this problem up. Because do I have a number at T here? There is a angle measure at T, correct? So I can do like that, according to whatever the statement is. And don't always go with the way it looks, because some of these they'll switch it up a little bit on you. Make sure you double check with the congruency statements. What's 5 divided by, or 65 divided by 5? A lot. Okay? And then the other variable here, the 4a, that goes with y. So again, the way you would do this is you would go 4a minus 4 equals, and it's whatever angle corresponds to y, which over here we wrote as s. So that's the reason I would know it sets up to that. What's 52 divided by 4?
I don't know.
What?
52 divided by 4, quick!
2 divided by 4?
It's
That's 13. Wait, what?
It's 13 again.